In this video, I'll show you where to find the most common agro-environmental datasets that has been organized into clear categories. I will also share project ideas you can build with them and walk you through one practical example that shows how one of these datasets can be used in a machine learning project. I have attached a file to this video that contains direct links to all the datasets we will discuss. My name is Meshach, and I'm a data scientist working on machine learning applications for agriculture and the environment. Why do agro-environmental datasets matter? They matter because almost every modern agricultural decision today is driven by data. From understanding what is growing on the land to predicting what will be harvested, these datasets power the intelligence behind smart and precision farming. They are commonly used for tasks such as crop classification from satellite imagery, early disease detection using weather and plant signals, yield prediction across seasons, and land use and land cover mapping at both local and regional scale. So let's move to the first category. The first category are the crop and plant level datasets, and an example is the plant village dataset, which I'm going to open in this link. And the plant village dataset is on Kaggle, and we can see this is the data, and this is the plant village dataset. It contains different crops and the diseases that they have. So you can see for pepper bell, the kind of disease that they have. You can see the potato diseases, and you can see tomato diseases at the same time. So this is what the file contains. You can see it on Kaggle. I have attached the link, as I've said at the start of this video. And you can even see the code to see some examples of projects that other people are building. Kaggle is usually the starting point for any kind of machine learning project whenever you want to learn how to do them. But specifically for agriculture, this plant village dataset will go far in helping you learn. Another example that we have under this category is the agriculture vision dataset. And the agriculture vision dataset is in this GitHub repository, and you will find instructions on how to use them, how to download them, and sometimes you even find examples of what they've done using the data in the past. You will see research papers that have used the data, and you can learn their process and try to reproduce whatever they've done before. And you can see this kind of dataset challenge that is mapping boundaries of a specific feature of the agricultural fields. So you can see it has been used in a challenge before, and you can replicate whatever has been done using the dataset. So that is the second one. And another one is the digital agriculture dataset, which is also on GitHub. You can find it here. You can see digital agriculture dataset, which is a curated list for publicly available data supporting development of artificial intelligence and robotic solution for agriculture. So if you're interested in robotics also, you can explore this. You can see the crop and weeds, plant instance and plant part, disease and plant health, scene understanding, and different things that you could benefit from using this dataset. Then we have the agriculture crop images. This one is on Kaggle, and I'm going to open it here. And you can see agriculture crop image dataset, and you can explore the dataset right here. You can see under Data Explorer. You can download it, and I'm going to be showing you how you can get dataset from Kaggle and demonstrate a specific machine learning project. Then under the same category, you have the deep weeds, which is a dataset that can help you to do weed classification. You can see a multi-class weed species image dataset for deep learning. So these are really interesting datasets that you can use for your machine learning project. If it comes to your mind as I explore these different datasets and you want me to build a specific project using one of these datasets, you can just put it in the comment section. After checking, I will rank the comments and see which one is the most common and try to produce a video using the dataset. Okay, then lastly, we have the crop yield prediction dataset. This is also on Kaggle. And you can see crop yield prediction dataset. This is also on Kaggle. So Kaggle is a place where you can have rich data sets for your project. You can see pesticides, rainfall, temperature, yield, and all others. So you can explore as much as you want. So the question you need to ask is, from this category, what are the project ideas I could build using this data set? So I have one here. For example, you can build a project on multi-crop leaf disease severity estimation. So you can go beyond classification by predicting disease severity levels from leaf images using convolutional neural networks and regression heads. So I know maybe if you're seeing this video, you don't even understand machine learning yet, but these are just some ideas. You will need to start from the beginning by doing little projects, then you expand from there. You can do weed versus crop segmentation for smart spraying project using the deep weed and agricultural vision data. You can do yield prediction from plant traits and weather signals. So there are several things that you can do, but these are just some of the ideas. And this is inside, I've listed these ideas also in the document that I've attached to this video for you to see the links and project ideas that you can build. The second category is the remote sensing and satellite dataset. So you have all these other datasets that are like images and regular tables. So they are not necessarily specific location bound, but we have remote sensing and satellite datasets that's where you can see the dataset for different location and you can do spatial analysis, or let me say spatial machine learning projects. So one of them is the Sentinel crop mapping dataset. We can see that also on GitHub. So you can see agricultural remote sensing dataset. You can see several ones that you can use. See barley remote sensing dataset for crop mapping. This is feed boundaries for agriculture, and you can do some projects using this dataset. We also see another dataset for land use land cover, which is from Cent for AgriNet. I'll show that here too. You can see land use land cover LUSC datasets. So they show you the link of different programs where you can get datasets for land cover. You can see Copernicus programs and for different years, 2024, 2022. And when you explore these repositories, there are clear instructions on how to use this dataset and download them and then build a project around it. The last one here is the crop harvest dataset from NASA. This can also be found on GitHub. And you can see, just come to the README file. So you can see the same thing. They even have a pipeline. And when you search online, you will also see papers that have consumed this data set, and you can just reproduce whatever they've done in those papers. And that is how you learn. And what are the project ideas that you can build using this? You have like crop type classification from multispectral Sentinel-2 imagery. And this is a kind of project where you use time series of spectral bands to classify crop types across seasons using different machine learning or deep learning model. And another one is field boundary detection using instant segmentation. You want to detect, okay, what are the boundaries of agricultural fields, so that if you have an analysis you want to do, you can contain your analysis to be within those boundaries. Then another one you can do is the early crop stress detection using vegetation indices. So in these days, it is always important, for example, for a farmer to know if a plant is stressed or not stressed, so that they can take action at specific times. So if you can build a model that can help the farmer to spot early stress on their field, that would be a beautiful thing to do. Then the third category that we're going to be talking about here is the climate and weather data. And the first one here is from IPAC. So you can see the different data sources. So from IPAC website, you can see the Persian rainfall data, RF rainfall data, and several of them. And the second one within this category of climate and weather data is the climate data store, which is from Copernicus, and it's rich in different like data sets. You can call this from an API and get the data and use it for different projects that you want to do. And I'm going to show one more in this category, which is the Climate Watch. And we can see that for Climate Watch. So you can search across platforms. Just search data by keyword or by country. So if I search for Ghana, for example, and I can see Ghana country page, and I can see the available data set that I have from greenhouse gas emission drivers, and I can begin to explore and download the one that I need from there. So that is how this works, and you can even visualize it right here. Project ideas that you can do with this: you can work on seasonal rainfall forecasting for agricultural planning. So you can build a model that can forecast, okay, when it will rain and when it will not rain, so that you can plan activities on your farm that has strong correlation with rainfall. Then another one is heat stress risk prediction for crops. So you can have a model that will predict whenever the temperature is really, really hot, when there's heat stress on your farmland, and the crop could face this kind of stress. So you can have a model that could predict that also. Then the other one is extreme weather impact analysis on crop yield. So you want to quantify the impact of drought, floods, and heat waves, and how they affect crop yield using like causal machine learning and using some explanatory machine learning technique like the SHARP-based method. So the fourth category, which is the last category over here, is the soil and land information. And you can get the soil information here under SMAP. So these are some different data products that they have. You see, business science data products. And you can see the things that you can get from these products according to the information that they have. So that is the first one for SMAP soil moisture, active and passive. And another one is the European soil database. So even though it is a European soil database, it doesn't necessarily mean sometimes that the data set they have is restricted to Europe. Usually they have like global data sets also, if you explore them based on location or countries. So you have this website where you can get the data set. And the last one under soil that I want to show is the one from FAO, which is the HWSD. So you can see harmonized world soil database dataset. I have used it for one project before. And the project idea that you can build, you can have the soil property prediction from sparse observations where you can predict soil organic carbon, pH, texture at high resolution using spatial and ML models. Another one is soil moisture downscaling using satellite and climate data. This is very important for agriculture. You can do land suitability classification for specific crops where you can say, okay, where in this terrain is suitable for a kind of crop that you want to use. These are the different things that you can do as a machine learning project. And I have one more category here, which is like an aggregate of the different categories. So there are platforms where if you go there, you will find data set for different options. One of them is Google Earth Engine. So on Google Earth Engine, you can find a lot of data set that you can use for agriculture and environment. So you can see a planetary scale platform for Earth and data science analysis. So this is one. Then on GitHub, like we've opened before, then one thing I want to talk about for Kaggle is if you just use the right search keyword, you will find like almost any data set that you want on Kaggle. So if I open Kaggle and I'm going to come to datasets, and under dataset, if I just say agriculture, you will see several datasets for agriculture directly, several datasets for agriculture. And the interesting thing about this is you don't just see the dataset, you can check the code and you can see what other people are building and you can just replicate it. So that is how you learn. That is how you learn. You can use all these to build different projects. However, I have the link for other platforms right there on the document when you open the link attached to the video. So let us go into seeing one of the projects where you can use a data set in agricultural and environment to build a machine learning model. So in this case, we're going to be doing this project where we'll be using the Kaggle data set from MRX, which is the plant disease data set. So let me open it in Kaggle so that we can see. So this is the plant village data set, and that I showed you the other time where we're going to be classifying the different plant diseases. So I'll come back to my notebook. So I'm using Google Colab, and you can access Google Colab by just going to colab.research.google.com. So later, I will be introducing Google Colab in another video on what you can do and how to get started with your project and options that you have. I import my libraries. Then the next thing is to define the path. So here, I just want to see one of the types of potato diseases. So here, I want to see this type of disease. I think I have it here. So this is early blight. So from here, I know the name of what I'm looking for, and I just want to see these images right there in my code. So I have the plant village, and I have this potato early blight, and I use the Kaggle hub to download the dataset. So I specify the directory, which is MRX plant disease, and you can see it over here. And I define the path, plant village, according to the path I have here, plant village and potato early blight folder. Then I'll run that and wait for it. So now I have all the files loaded, and to see the images, I want to see the top two image there, and you can see this is an example of a potato disease. See, this is an example of a potato disease, right? So this is an early blight disease that you have for potato. So now let's look at an example of a project that we can build. So I'm going to be building a simple classification model using logistic regression. So there'll be another video that'll be coming up on my YouTube channel here where I'm going to be explaining different machine learning models and be applying them to real life use cases. So I import all the libraries that I need here, and I'm specifying plant village only. So initially I specify the early blight, but here I need to access all the images that are inside the folder of the plant village. So I will run this, and you can see it has loaded all the folder that is required, or that are required for me to do my analysis. And here I want to get what are the classes of those diseases. And to get what are the classes of those diseases, it is just to capture the name of each folder that we have. So I have the names of each of the folders, and going back, I can run it. You can see the number of classes. I have 15, just like what I have here. So I have 15 of these folders showing the different classes. Now I'll visualize the class count just to see. So these are the different classes. Maybe I'll zoom out a bit so you can see the different classes. You can see the class distribution. So you have the pepper bell, you have the potato the healthy one, the leaf mode and all. But you can see these classes that they are imbalanced. So usually in a standard machine learning project, I will normally do some class balancing. But here I'm just showcasing the model. This is not the deep project. So in the main project of this plant disease, I'm going to be giving explanation of individual steps that I'm going to be taking, but this is just a demo. So I'll show you an example of sample images right now with their name. So I'm loading this now from the database, and you can see in each category, I'm showing an example of the disease. You can say healthy tomato leaf. So you can see this. The early blight looks this way. For the pepper bell, you can see the kind of disease that it has, and the tomato when it is late blight, and different things that happen to tomatoes. So we need to load the images for training. So I will run this. I already have this code pre-written, and just to see the images that I need. We have images that are like more than 1,000 right there. So for me to make things easy for myself, because I don't want to take time, I'm just saying maximum image per class. So I have 150. So in each class, I'm having 150 images. So that is what I'm doing, and I'll load it. So just to see. So now they are being loaded, and you can see in this dimension, you have the 2,250 images in total, which is 150 multiplied by 15. So if you want to verify, I can say 150 multiplied by 15. So you can see 2,250. So that's that. Then 224 by 224 is the dimension of the image. Then the 3 that we have there is just the RGB that I'm getting from the image. So it's more like the color spectrum. So that is what I'm doing here. So that has been loaded, and I can check the shape of my label, which is 2,250, and the label is just those classes of diseases that we have. So for machine learning projects, we need to have our train and test. I run my train and test, and for me to use it, I need to flatten it, because currently I have the image dimension as part of the shape, and I have the RGB as part of the shape. I have the length of the images as part of the shape, but here I want to flatten it so I can have the information I need. So it's flattened, then I'm training my logistic regression at the same time. So I just wait for it to run. It may take a bit of time for it to run. Now our model has finished training. That took about 5 minutes to train, but there's a way we can make this better in the main project later. So now we have a model. So for me to use the model, I just want to have my class names. So which is to get the names of those folders, then have them as my class names. So when I print it, you can see an example where I have class names, and you can see, so it becomes a list of the different diseases, so which we grabbed from the folder names. So that is what the class name is. So I will use my model that has been trained, which is the logistic regression. Then I can use it to predict and check the accuracy. So this is the accuracy from the prediction. You can see the precision, the recall, the F1 score. So the video that will be explaining using classification algorithms, you will be getting deeper explanation on this. This is just a demo right now. So what I want to do is to make prediction on a single image and see if my model will get it correctly. So I have this image, which is the potato early blight image, and I want to see when I predict if it's going to get it. So I have this function to load a random image. So I'm loading a random image, and the random image, I'm passing it into this X test that I want to use for the prediction, and that will load. This is the random image that I chose from the folder, and this is potato early blight. So I'm going to be running the prediction to see if my model is predicting correctly. So drum rolls. Wow, you can see the model is wrong. So it predicted it as late blight, and it's actually early blight. So because it is random, I'm going to run it again to see if to get another image. So let's see if it will get this image correctly. Wow, it got this correctly. This is early blight, early blight. So I'm not surprised, because you can see the accuracy is about 0.46. It's very poor. The model is not well trained. So we can do it better in a full image classification project using machine learning and agricultural data set. So that is what you have as a demo. You can see how we took the data set from Cargo, and we trained a model on it, and we could verify the performance of the model by using it to make predictions. Here's a challenge for you. Pick one data set from this video, build a simple baseline model, and tag me on LinkedIn or in the comments of the post. My name is Meshach Aderele. If you search for Meshach Aderele on LinkedIn, you will find me on LinkedIn. So that is it. And remember to comment which data set you want me to use for a machine learning project tutorial, and I'll surely do something that you will learn a lot from. So thank you.